A good day to everyone and welcome to the third video of the grade 10 second term video series. I'm Sanjay sir. In the previous video we discussed about the conversion of a decimal number to any number system, that is a decimal number to binary or decimal number to octal or a decimal number to hexadecimal. In this video we will be seeing the conversion of any number system into a decimal number, that is the other way around. We will be using a method called a place value method for this. So in the previous videos we discussed about 4 methods of conversions, and this will be the second method that we will be discussing in this video. So let's start with a binary to decimal conversion. In a binary to decimal conversion, let's look at this binary number 101101. Now I need to convert this binary number into a decimal value. So for that I will first spread out these numbers because we need some space to write the values in between. So since this is a binary number, I'm going to write the place values of 2 to the power 0 to the number that we have here. So I will start with 2 to the power 0 starting from my right side. So the place value for the first digit from the right will have the value 2 to the power 0. So that is the place value for the first digit. Then it will go on like 2 to the power 1, 2 to the power 2, 3, 4, 5 and 6. Now these place values are going to have a certain value. Now 2 to the power 0 is 1. Then 2 to the power 1 will be 2. And 2 to the power 2 will give you the value 4. Then 8, 16, 32 and 64. So these will be the place values of each position of the binary number. Now we will not need this part, so I will just cancel it off. Now for our calculation we will have to consider these two numbers. I will have to multiply the binary number with its corresponding place value and add them up to get our decimal value. So first I will start from the left, that is 64 and 1. So I'm going to multiply 64 into 1. I'm going to write that down there. The next value that we have to consider is 0 into 32. We know that anything into 0 will give you the value 0. So whenever the binary number is 0, we will not consider that number. Then we'll move on to the next one. 1 into 16. I will write that down. Note that we are going to add the products of all these numbers. The addition sign is available here. So 64 into 1 plus 16 into 1. Next we have 1 into 8. Then another 0 is available, so I'm not going to consider that part. Then I will move on to the next one, that is 2 into 1, and the last one is 1 into 1. When I multiply and add these numbers up, I'm getting the value 91. So this would be my decimal value for this binary number. So that is how you calculate a binary number's decimal value using the place value method. Now to convert any other number, that is octal and hexadecimal, we use a very similar method. The only thing that changes is the place values. Let's look at octal to decimal. We are going to convert this particular octal number, that is 746 base 8 octal number, to a decimal number. So I will take off the base value and I will spread out these numbers, and this time instead of 2 to the power 0 I am going to use 8 to the power 0 to 8 to the power 2 here, because we have only 3 digits. 8 to the power 0 to 8 to the power 2, because I am converting an octal number to decimal this time. So the base values, place values only we are going to use. So 8 to the power 0 is 1, 8 to the power 1 is 8, and 8 to the power 2 will give me 64. Now I will not need the power of the 8, so I will take that off. Now we will multiply these two numbers. 7 into 64 plus 4 into 8 plus 1 into 6. So when I add them up, I am going to get the value 1352. So the decimal value for the octal number 746 would be 1352. Then let's look at the next example, that is converting a hexadecimal number into a decimal number. Let's consider this AB3 base 16. I'll take off the base and I'll spread these three numbers just like we did before. This time I'm going to use the place values of 16 base. So 16 to the power 0, 16 to the power 1 and 16 to the power 2. The values of these places will be 1, 16 and 256. Now I will have to take this off and multiply these two numbers. Remember, in hexadecimal, whenever we get an alphabet in the values, we have to convert it first into the corresponding decimal value. So A will be 10 and B will be 11. Now we can do the multiplication. 10 into 256 would give me 2560. Then 11 into 16. Then 3 into 1, which will give me 2739. That is the decimal value of hexadecimal number AB3. Now you can see that whenever I get the answer for the decimal number, I am not writing the base 10 here. If the base value is not written, remember it is denoting that it is a decimal number. If the base value is written, that means it will be some other numbers. You can write 10 as the base, still it will be a decimal number. If you don't write the base, still it is going to be a decimal number. Remember that. Now that we know how to convert these numbers, let's do some exercises. Converting to binary, converting to octal and converting to hexadecimal. Now all these are decimal numbers and I want you all to try converting them into these respective number systems. And the second exercise, I would like you all to convert all these numbers of different number systems. The first group has binary numbers, second group has octal numbers, and the third group is consisting of hexadecimal numbers. I want you to try the previous one and this exercise and see if you all are getting the correct values. You can write the answers in the comments below. So that's it for today's video. So I want you all to try out those exercises and see how good you are with all these conversions. So these are the first two methods of conversion that we are going to learn, and there are two more conversions which will be done in the next video. I will be doing both those conversions which are very similar to each other, the 3-digit and the 4-digit method, in the next video. So until I meet you all in the next video, This is Sanjay sir signing off. Take care and God bless you.